Hello, Genius Minds. This is Newton back at. So sorry to all of you because I take a lot of time to make this video because my home was shifting. So sorry again. Let's start with this video. In this video, we are talking about force and its derivation. So force is a part of Newton's second law of motion, which states that the rate of change of momentum of a body is directly proportional to the force applied to the body and also acts on the direction of the force applied. So basically, force is equal to mass multiplied by acceleration, and we all know that, and it's a very famous phrase. So this is the only theory part. Let's talk about why force is equal to mass multiplied by acceleration of a body. So let's write the heading first, that derive. Okay, F is equal to m multiplied by a, and that's the thing we have to prove or state. Okay, I think the focus is going bad. Okay, that's nice. Let's talk. So let a body of mass m is moving with initial velocity u. After some time t, it changes its velocity to v. Okay, so basically we know that the force is equal to rate of change in momentum. So in rate of change in momentum we need two momentum, and that's p1 and p2. Here we got at first one momentum, one velocity, that's initial velocity u, and then a final velocity v. And to change from u to v it takes some time t, and that's the times taken, and the mass will be a constant, means mass of a particular body is constant. Now the initial momentum, you have to find two momentum. So this is the initial momentum is equal to mass of the body, just simply mass multiplied by initial velocity. Initial, oh I missed the I, implies p1. I state the initial momentum as p1 is equal to mass multiplied by u. And now again we have to find the final velocity, sorry, final momentum, yeah, final momentum is equal to mass of the same body multiplied by final velocity, means v. We will write it in the next step. Implies p2, I state the final momentum as p2 is equal to mass multiplied by v. So now let us write the rate of change in momentum is equal to mv minus mu by t, and that's simple because we got the final momentum as mv and the initial momentum as mu. So let me write in the joint form. Okay, so we how to got the rate of change in momentum, and that is final momentum minus initial momentum by time taken. And if I take mass common, we get v minus u by t multiplied by m multiplied by v minus u by t, and I took it as equation I. Okay, so let's continue. So we know that AT is equal to V minus U, and that's is first equation of motion from the motion chapter. Okay, so A is equal to V minus U by T. That's the formula. Now in the equation I becomes, now the equation I becomes the rate of change in momentum is equal to m multiplied by v minus u by t, and that's from the equation I. Now I can write it as m multiplied by a. Okay, so we have to remember from the Newton's second law of motion that force is directly proportional to the rate of change in momentum. So we can write here that according to Newton's second law of motion, and yeah, law of motion and equation of motion are very different. F is directly proportional to ma, where F is equal to force, mass, m is equal to mass, and a is equal to acceleration of the body. So to convert it into an equation, we can put a constant, and that constant will be k. Now putting a constant k, where the value of k is 0, so the value of k is 1, the value of k is 1, we get F is equal to k m a, implies F is equal to mass multiplied by acceleration. So this is how we got force is equal to mass into acceleration, means force applied on a body is equal to mass of the body multiplied by acceleration produced in that body. So from here we got some points that force is directly proportional to mass as well as acceleration of the body, but mass and acceleration are inversely proportional. It means that if the mass of a body is larger, then the acceleration will be smaller with the same amount of force as in a smaller body with a body of smaller mass having a higher acceleration with the same amount of force. So thanks for watching this video. Hope you like this video. Please drop a comment in the comment section, and yeah, do like and sub. Thanks for watching. Bye bye.